Hello, my name is Laura Maria Caldarone, producer and host of The Long Haul, an online series on long COVID where we speak to long haulers and their loved ones about their lived experiences with long COVID and where we look at the science of this debilitating disease. With us today, we have Dr. Jeremy Rossman, virologist and president of Research Aid Networks. Hi, Jeremy.
Hello, nice to see you.
Nice to see you. So let's start. First week of 2022, year 3 of the coronavirus pandemic, and there's so much to talk about. And before we get into the main reason why we're having this talk, can you tell us the basics first? What is long COVID?
Always a good idea to start with the basics, especially because, making sure that we're all working from a similar understanding of what we're talking about, not only for this episode, but for all the episodes in this series is incredibly important. So when we're talking about long COVID, the World Health Organization has recently come up with a case definition to try and help all of us work on the same page as to what we're talking about when we're talking about long COVID. And the idea here is that this is a condition that occurs post either a probable or confirmed case of SARS-CoV-2 infection. Now, this involves symptoms that have persisted for at least 2 months, but can persist for longer than that. These symptoms cannot be explained by an alternative diagnosis or a different condition. And these symptoms include a wide range of symptoms, but specifically involve things like fatigue, post-exertional malaise, shortness of breath, cognitive dysfunction, and can be a wide range of symptoms, but they tend to have a very strong impact on people's everyday functioning. Now, these symptoms can be new and occur after recovery from the initial infection, or these symptoms can persist from the initial illness. But in both cases, they can fluctuate over time, and sometimes you get recovery and relapses. So there's a lot of variability here from patient to patient and within a patient over time, but these tend to be the core parameters that we're talking about when we look at long COVID.
And if I may add, one thing that we have seen, in the last couple of years and throughout this online series of ours, is the fact that long COVID does also affect the young and the healthy. They were previously healthy before getting infected and having COVID-19, and they went on to having long COVID.
Exactly. It's a really critical point because, we're talking about this case definition, but this doesn't just apply to, say, people with underlying health conditions. It doesn't apply just to the elderly. This is something that can happen to anybody of any age. We're seeing long COVID in healthy young adults. We're seeing long COVID in kids. And importantly, it doesn't correlate with how severe your initial infection was. So people can have a very severe initial infection and go on to develop long COVID, but people can also have an incredibly mild initial infection and go on to develop long COVID that is much more severe than the initial infection was. So it can affect anybody.
It can affect anybody. And just to continue from what you just said, because it's one of the questions that you are always asked, right? Okay, what is the probability of me getting long COVID after I've had COVID? What is the latest right now? I know that different studies say different things depending on what was studied, when it was studied, but just to start the year with the latest information, what can you tell us?
So this is a very difficult thing to accurately assess, especially because many countries are not reporting data on long COVID. So, you can go onto all these online sources and track how many new cases or the case positivity rate in your country, but there are very few dashboards that show anything in terms of updated long COVID numbers or prevalence data. So this is a little bit difficult. But what we do know is the Office of National Statistics in the UK has been doing a pretty good job in keeping track of that. And they estimate that somewhere in the range of about 11% of cases go on to develop symptoms that last at least 12 weeks. But actually, we have a new study that was actually just published and is quite helpful in this because it's what's known as a meta-analysis. So when we're looking at prevalence data, we have all sorts of studies that have been published. Some of them are really good studies, some of them are poor studies, some of them have a lot of patients, some have very few patients, and they tend to have a wide range of prevalence data that they report. But this study actually went and did an analysis of all of these studies and sort of compiled that data together to look at, what we can sort of be more assured about. And so one of the things that they saw was that they looked at the prevalence of fatigue or the prevalence of cognitive impairment following on acute COVID infection, and the prevalence of this lasting at least 12 weeks. And what they saw was that 32% of cases developed fatigue that lasted for at least 12 weeks. And 22% of cases developed cognitive impairment that lasted for at least 12 weeks. But the sort of added, that's disturbing enough in and of itself, but the added really disturbing part was that when they looked at 12 weeks versus 6 months or longer, they saw that that prevalence didn't really decrease much, maybe about 1 percentage point, so that it looks like, at least in that 12 weeks to 6 month period, you're not seeing a lot of improvement, at least in terms of fatigue and cognitive impairment. And remember that there's a wide range of symptoms that we're talking about here. These are only 2, but it really goes to show that this is a condition that is affecting a very large number of people in countries around the world.
And when you say cognitive impairment, these are things that prevent you from doing your normal daily life. Can you just very quickly tell us a little bit more of when you say cognitive impairment, what does it mean?
So when we're talking about cognitive impairment, this is sort of a broad category that can encompass a lot of individual symptoms brought together. But this is sort of anything that's really affecting how your ability to think, your ability to sort of operate. And like you said, these are things that can really have a very profound effect on day-to-day life, whether that's, just remembering things, short-term memory, or whether that's things like, ability to be writing clearly, or, things like brain fog, which is something that we hear a lot about. So it's a wide range of symptoms, but it's all grouped together. And yeah, as you said, both fatigue and all of these aspects of cognitive impairment can really dramatically affect everybody's day-to-day life.
Cognitive impairment and fatigue, that clearly shows that long COVID does affect too many. On this note, I think we can really go on to the preprint, which is one of the preprints, which is one of the main reasons of the talk of ours. And just to give a little background, at the end of 2021, there was a preprint called SARS-CoV-2 Infection and Persistent Throughout the Human Body and Brain that did the rounds in news outlets and social media on a study that found evidence of the virus persistence in organ systems throughout the body. Before you tell us more about the study and what does this actually mean, again, I would like you to give us a reminder in layman terms, what is a preprint?
Yes, this is really important because right now we're preprints have been around for a while, but they're really taking on a real importance right now because we have all sorts of studies, but what is a peer-reviewed study versus a preprint study, and what is the impact of that when we're talking about that? And so just to sort of give an overview of how the publication process works in the sciences. The idea is that you'll have a research group that does a study. And they finish the study, they get all the data, they analyze the data, and they write a paper on that. And that's all great. But normally what would happen is that you would take that paper and then you would send that paper to an academic journal, a publishing organization, something like Nature, which this preprint that you mentioned is currently being considered by. And that journal does something called peer review. So they have editors at the journal that look through the paper and assess it and say, okay, this paper seems good, but those editors aren't experts in the field, so they can't assess it in any detail. And so what they do is they send that paper to a couple experts in the field. So if you're talking about a paper on viral persistence, they're going to send it to experts that have done research and worked in the field of viral persistence so that they know the methods, they know the background, they know the field, and they can go read through the paper. They can go analyze the data. They can look at all the figures and really assess and say, okay, does this paper look like it was done appropriately? Do the conclusions match what the data shows? Does the data that they're showing, does that convey the data well? Does it convey what was actually done? So it's not a way in which the data is validated, because that requires additional experiments, but it's a way of an additional independent set of eyes looking at the data, looking at the paper and saying, yeah, this makes sense, it's consistent, it looks like it was done well, the data is presented well, nothing is really being obscured, or it's accurate in terms of their interpretations. So that's the whole peer review process. But the problem is, as you would imagine, that can take a long time. It takes time for the journal to assess it, to send it out to the reviewers. It takes time to review a paper in that depth. And then after those reviews happen, the authors have a chance to revise their manuscript to address anything that wasn't perhaps expressed clearly in the manuscript, or to do additional experiments if that was deemed necessary. That whole process can take weeks to months to sometimes even years. And in the middle of a pandemic, that's not the time where we want to wait, months for really important data to come out. And so that's where preprints come in. So the idea of preprints is that you provide sort of a placeholder paper, that the paper that the authors send to the journal, they can also upload to these preprint servers. And these are things like Research Square, which is where this preprint is, but can also be things like medRxiv or bioRxiv or SSRN. There are quite a few of them out there right now. But basically, all they do is they post that manuscript that the authors send to the journal. So it's not been reviewed by other scientists. It's just the author's raw work. And so that allows this message and this data to get out there quickly so that people can be starting to think about it, so that we can revise other experiments, other research projects, start to explore new directions. But it always has to be viewed with a grain of salt, because it hasn't had that in-depth review. And so, whether there's something in the data analysis or something in the methods or something in the conclusion, basically anything that's a preprint is subject to change, or perhaps sometimes subject to being shown to be not scientifically valid and should never get published, and sometimes doesn't get published. So it needs to be taken with that grain of salt and to be looked at carefully as saying, okay, well, it hasn't been reviewed by the scientists, so we need to do extra scrutiny of it. And to also know that we're going to have to wait until we get those reviews back, until we see the article published, to know if it holds up in exactly the same way it's currently published.
And I mean, the way we've seen it in this pandemic is that we've seen a lot of preprints, just so many. And of course, it's a question of time, right? Because some information that comes out of these preprints can really change the course of a country's pandemic response, right?
Exactly. It really can. And this is why preprints are both so important, but also so dangerous, because sometimes preprints get picked up and reported on as if they've already had that review, as if other scientists have already said, yeah, this all holds up. And sometimes they don't. Frequently they do, but they don't always. And so it has to be interpreted with a little bit extra caution and just that awareness that, it might change during the review process.
And from also, at least what I've seen, there's a lot of loss in translation from the scientific way of explaining and speaking to what we see the media saying. And then, so.
Of course, I mean, because, this is also, not completely changed, but it's been really emphasized during the course of the pandemic that, scientists write papers typically for other scientists or for the scientific community. But, these are papers that have direct impacts on society, on medicine, on practice. And so there's that sort of slight disconnect of the papers being written for a scientific audience, but being directly applied and picked up by the media and used in society. And so sometimes you get scientists that are really good at providing that translation, but not always. And this tends to be emphasized with preprints, where it's so much research coming out so fast that often you don't have that translation going along with it.
Yeah. So then give us all the information on this preprint. So not necessarily for only for a scientific audience, but also for the rest.
So this was an incredibly interesting paper. And, we've talked about some research highlights on the long haul before, studies that really have the potential to make a real impact at, to the patient level, whether that's understanding the disease, whether that's advocacy for getting more support, or whether that's even looking at treatment. And so this is one of those really potentially very important papers because it gives an idea of a mechanism by which the disease might be occurring. Again, we don't know for sure, but it's got a lot of potential, because one of the things that people have been looking for quite a while in the course of the pandemic was, of course, to understand why in that 10 to 30% of patients symptoms persist. And one of the sort of original ideas was, well, maybe symptoms persist because those patients never clear the virus, that the virus persists, and so symptoms persist. And there have been some papers here and there that have shown a little bit of evidence. Maybe they found a little bit of viral RNA in some tissue or some viral proteins somewhere in the body. But it's always been a very limited number of patients, and it's been very difficult to make any conclusions. But this is the first paper that has done an incredibly in-depth and thorough analysis and has really identified viral persistence as something that potentially occurs quite regularly. So continuing on with that, what they showed Well, let's even back up. Before I get into what they showed, let me just talk a little bit about what they did, because this was an incredibly involved study and took a really long time, which is part of the reason why it's taken so long until we have any of this data. So what the authors really wanted to see was that if they looked throughout the body at various points in time after COVID infection, do they see the presence of the virus? And if they do see the presence of the virus, where in the body did they see the presence of the virus? And so in order to do this and to do this robustly, what they looked at was they looked at 44 patients that had confirmed COVID infections. These are PCR confirmed COVID infections that unfortunately died. And the majority of these patients died of complications from the acute COVID infection or from long-term effects of the acute COVID infection. But some of the patients had mild infections that ended up dying from an unrelated condition. And even one of the cases here was actually, unfortunately, in a 6-year-old child. So with all of these cases, they collected samples throughout the body. And they looked in everything from the brain to the cardiovascular system, to the liver, to the kidneys, to the lungs, trying to find the virus. And what they did was they did a whole series of steps. They looked first to say, do we see any presence of viral RNA? Because that's a very simple thing to do, but it's a little bit less sensitive, because do you have viral RNA or do you have the whole virus? And if you have the whole virus, is it growing? Is it replicating? Is it just hanging out? Lots of questions here. So they started by saying, do we see presence of the viral RNA? And then they went and they said, do we see any evidence of viral replication occurring? And then they actually went to try and isolate live virus from the tissues. And so this is only 44 patients. And most of the patients had an underlying comorbidity. And the majority of the patients were actually men. So that changes the gender balance in terms of what we see typically with long COVID. And of course, all of these patients had died. So it is an atypical sample. But what they found was that in all 44 patients, they found that the virus had left the respiratory system. So we're always talking about COVID being a respiratory disease, because that's how it spreads. It spreads in the air. And that means that the first point you get infected is something like your nose, your throat, your lungs. But we have a lot of data from many studies that says COVID causes disease that is beyond just the respiratory system. And so what they found was that in all 44 patients, they found disease beyond the respiratory system. They found that the virus had gotten out of the respiratory system and spread throughout the body. So that's the first really important thing. But the second thing is that they found that in all patients, the virus had persisted beyond the acute infection. So even after that initial infection had resolved, patients still had presence of the virus. So they found evidence of viral RNA out to 7.5 months. They found replicating virus out to 3 months. And they were also able to isolate live virus. So it's not just a little bit of the virus that seems to persist, but it actually seems to be the virus that persists. And when we look and say, okay, well, what did they actually see? I mean, they saw a virus that had been throughout the body. I mean, the respiratory tract, the cardiovascular system, immune system, the gastrointestinal system, liver, kidneys, endocrine organs, the reproductive system, nerves, and the brain. And it's a really scary thing because, I mean, when they looked, they said that 90% of the patients that they looked at had viral RNA that was present in the brain that persisted. So it was a really well done study that had a tremendous amount of data. Yes, it's limited to 44 patients. It's limited to this sort of atypical cohort when you think of long COVID. But they did find this disseminated virus, and they found persistence of the virus. So this was a really huge result that has potentially very profound implications. But I want to mention sort of one additional caveat here. One additional sort of point that we should take into account is that one of the things that they don't mention in the study is whether or not the patients that they're looking at say 3 months or 7.5 months, if they had persistent symptoms, or if their infection had recovered and their symptoms had recovered before they unfortunately died. And we don't know that. But the answer to that question has very important implications, because does that mean that on one hand, if in fact those patients had persistent symptoms, then maybe this is why long COVID is occurring, is that the virus is sticking around. And so the disease caused by the virus is continuing. But on the other hand, if everybody has persistent virus, and if the virus disseminates throughout the body in everybody, even if they don't have persistent symptoms, well, then first of all, that's incredibly concerning, because what the long-term implications of that really remains to be seen. But then it also, begs the question of, how does long COVID disease occur? Is that because in a subset of those patients, they have an abnormal immune response that continues this persistent virus? Is it because the virus behaves a little bit differently or is in different sites of the body? A lot of big questions stemming from this paper that we don't know yet. So exactly how it will play out and what the implications are, we don't know. But it's a really interesting study that offers that first very concrete step to saying, maybe we're getting closer to understanding how long COVID disease is occurring. And if, in fact, we get a better idea of how it's occurring, then we might be closer to starting to say, how can we treat this?
You did mention, yes, it's a small group of people. It's only 44 patients, and actually, you said one of them, unfortunately, was a child. But one of the things that I wanted to get a little bit more into detail is, while I was reading the study, I saw it clearly states that over 90% of these patients had at least one comorbidity. Yes. And first, again, just, a recap, what exactly does that mean? What is the difference between comorbidity and underlying health condition? And if you can speak a little bit about these comorbidities that these patients had.
Yeah, it's really important because, we hear so much about this idea of comorbidities or things that sort of predispose people to more severe disease. And so when we're talking about this, when we're talking about viral persistence, of course, anything that's making people more susceptible to the virus or to severe disease has really important implications to say, how generalizable are these results back to the population? And so, we hear two terms often. One is this underlying health conditions, and one is comorbidities. And basically, underlying health conditions is that, okay, before you got COVID, did you have any other health conditions that were wrong? Did you have, I don't know, athlete's foot or something like that. Like that might be an underlying condition, something that, you have some medical condition that maybe makes you unwell, but it doesn't necessarily affect the disease outcome. Whereas a comorbidity, what we're talking about there, we're specifically talking about those underlying health conditions that directly affect the disease outcome for COVID-19. So basically, two of the most prevalent comorbidities that were seen in this study was, obesity and hypertension or high blood pressure. And this was seen in the majority of patients in this study. And we know that having either hypertension or being obese increases your risk of getting severe COVID disease. And so this is really important to keep in mind. But that's sort of the distinction is it an underlying health condition? Is it some, pre-existing medical condition that predisposes you to more severe disease or to even getting infected? Or is it, sort of an unrelated pre-existing health condition that doesn't necessarily affect the COVID disease?
And with these two examples that you gave of comorbidity, of hypertension and obesity that we see in these patients of the study, if you look at a country like the US, where you are at, that is almost half of the population.
Exactly. So, we look at this idea, you can look at this study, which was done by the National Institutes of Health in the US. So from a US study population, and you could say, well, the majority of the people in the study had these pre-existing comorbidities. They had obesity or they had hypertension. And so you could say, well, maybe that means that these results don't really apply to the general population in the US. But as you said, if you look for the prevalence of obesity and hypertension in the US population as a whole, well, 42% of the US population has been defined by the US CDC as being obese. And the prevalence of hypertension in the US is 47%. So almost half of the population has these conditions. And so it's really important because that means that even though these patients are perhaps atypical for a perfectly healthy subset, in fact, they do represent more of the overall US population. So it's important. And we don't really know, from this study, we don't know, would the effect have been exactly the same if the patients had been perfectly healthy? That's one of the things that we cannot know from this, but it does have really important implications because so much of the population does have these comorbidities.
Yeah. And this is obviously, we're talking about the United States, but
Exactly.
most countries have very similar problems.
Exactly. And this is not atypical in many countries around the world. And many countries do have far lower rates of hypertension and obesity, but in some areas and in some subsets of the population, these rates can be even higher. So there's still a lot more to be figured out from the study. We don't know exactly how the virus persists or why the virus persists. We don't know exactly how it causes disease, and we don't know how that disease persists. But this gives us some really concrete information. And of course, one of the sort of interesting things and one of the questions that seems to be obvious is if you look at these patients that are, say, 7.5 months after acute infection in this study and said, well, okay, so we found persistent RNA or we found persistent virus. Well, do you see disease? Do you see disease caused by that? And that was one of the sort of more difficult, but sort of strange, but also very informative things is that they didn't see much disease caused by the virus, especially outside of the respiratory system. They still saw some level of disease caused by the virus in the respiratory system, which to an extent makes sense because most of these patients had had severe acute COVID, but there wasn't a lot of disease that was really evident. But just because in these specific assays, they didn't see overt disease doesn't mean that it's not occurring. It's just perhaps difficult to see on specific assays. So of course, just because they didn't see any signs of disease in this specific assay doesn't mean that there weren't any, that there wasn't any tissue damage that was caused. And actually, this is very interesting because it correlates with an additional study that was done very recently out of Hamburg, where they looked at over 400 people post-COVID infection. And what they saw was that in that the majority of people had what they're calling subclinical damage in multiple organs. And this was damage that might not be detected on most common assays, but that if you looked in enough detail, you were actually seeing damage to multiple different organ systems. So this could be very related to that persistence paper, and all looking at, what kind of disease is being caused by long COVID and perhaps by persistent virus, and that, it might not be detectable by most common, say, blood tests, but that the damage is there, that there is real and observable multi-organ damage that is occurring. And for example, in the persistence paper, they did note that one of the damages that they saw was, I guess it's not exactly damage, but one of the sort of potential disease mechanisms that they saw was in the brain. In the majority of participants, they saw what they're calling vascular congestion. And this was a high amount of platelets, which are the cells involved in clotting, sort of all jammed together in blood vessels in the brain in some of these cases. And so this is very interesting and relates back to what we've been sort of previously hearing a lot about, this idea of clotting, that clotting might have a really strong role both in acute COVID as well as long COVID, which is actually very related to the next preprint paper that we wanted to talk about.
You perfectly brought us to the next topic. So if you can continue talking about that, because just as you know, this week also one thing that has been in the news is there was an article recently from The Guardian that spoke about these microclots. The name of the article is "Could Microclots Help Explain the Mystery of Long COVID?" An article written by Professor Ressia Pretorius, and she speaks about a study that was done. So please tell us what it means, to talk to us about the study, and yeah.
Certainly. So, first of all, to just set the stage a little bit, we're talking about clotting here. And clotting is, of course, the body's natural defense to wounds, ways of sort of sticking little bits of protein together to make sure that you close a wound so that you can actually start to repair blood vessels and stop bleeding. So clotting is a really important process, but a lot of the proteins involved in clotting also have roles in the immune system and relations to inflammation. And so one of the things that was seen sort of fairly early on in acute COVID disease is that there tends to be a lot of clotting observed and clotting disorders observed. So you can look in the blood for markers of clotting and you can see elevated levels. We talk about, patients having clots, and this can potentially be incredibly severe or fatal in some patients. And so we've seen this a lot during acute COVID. But now we're sort of talking about clotting in long COVID. And there have been some reports that have speculated about this. We've seen some papers that have said, okay, we're seeing elevated levels of clotting markers in the blood of long COVID patients, but they tend to be small sample sizes. And then you also have papers that say, okay, there's no increase in these factors. So there's been some sort of controversial data, or not necessarily controversial data, but we've got data on both sides there. But what this paper is doing is this paper is building off of a previously peer-reviewed published paper that the group also wrote that was looking at this sort of atypical clotting. And, basically they're saying that they're seeing evidence of clots forming in long COVID patients that are sort of long lasting. Most clots can be sort of broken down by the body. They help stop the bleeding. And then once the tissue is repaired, the body is able to break down the clots. And that's sort of the normal process. But what they were saying is that they were finding clots that were resistant to being broken down, that were persisting in the body for a very long time, were forming these large sort of clotting aggregates, and that they tended to be very inflammatory aggregates, so that they're not only forming these clots, and of course clots can be very dangerous because they can obstruct the blood flow, but it was also suggested that these clots are contributing to sort of persistent inflammation. Now, the authors also showed that this sort of abnormal clotting might be directly triggered by the viral spike protein, so that it's not some random part of the virus, it's not some sort of the body responding to the virus, but that something about the spike protein itself might actually be triggering formation of these abnormal clots. And so that sort of led on to their current preprint publication, again, which is also at that Research Square preprint. And as we mentioned before, that this is a preprint, it has not been peer reviewed yet, but they were suggesting and saying, well, if there is this persistent abnormal clotting in long COVID, then maybe if we're able to treat that, if we're able to do things that sort of disrupt those clots and prevent more clots from forming, then maybe that would help resolve symptoms. And so, and that was exactly what they saw. And it's very interesting, but there are a couple sort of limitations that we need to point out for this. So first of all, when they first identified these abnormal clots, which again, is not something that has been consistently reported in other publications, they had 13 healthy patients and 11 long COVID patients. And so that was the comparison. And they were seeing more of these persistent abnormal clots in long COVID patients. So it's not a huge study group. It was very limited. And unfortunately, it used a very difficult technique, something where you actually had to isolate the blood and you had to work with it in a laboratory on a microscope. It's not a standard blood assay that can be done. So it's quite involved and very difficult to specifically quantify exactly what is going on. So it's a difficult assay, not really done widely. When you go to the treatment, what they did is they started with 70 long COVID patients. And of those 70 long COVID patients, they looked in the blood of everybody and found evidence of these clots in everybody. We don't know exactly how much of it was in everybody. We don't know the range. Is it just a little bit? Is it a lot? Is there a huge variability? But what they did was in 24 of those 70 patients, they put them on these drugs that are designed to stop clotting and to sort of help break down the clots that existed. And they saw very good outcomes in terms of sort of reduction of these clots and patient symptoms. But one of the sort of additional big, hesitations about this paper and the reasons why, I'm not saying, okay, we now have a treatment for long COVID, because we're absolutely not there yet. And the additional reason for that is that they looked specifically and on this treatment, it was on 70 long COVID patients, but they didn't have the same sample of patients that had acute COVID, but then recovered. And so we don't know, is this sort of persistent clotting morphology, are these persistent clots something that happens to everybody? after COVID, you form these clots because of the spike protein. They stick around because they're very resistant and maybe slowly break down over time, but they're not what causes disease. It's just something that happens in everybody. And so without that sort of recovered control, because they're even in the first identification paper, they were just comparing healthy controls versus long COVID. So we don't know for sure that the presence of those clots is associated with what we're seeing in terms of symptoms. But we don't know that it's not. It very well could be. There's a lot of publications, there's a lot of data that is pointing to different areas of clotting. And it's actually very interesting because if you go back to that viral persistence preprint and say, well, we're seeing evidence of the virus persisting. Well, if you have persistent virus, maybe you have persistent spike protein. And if you have persistent spike protein, maybe you're getting continual spike protein induced clotting. And that is causing maybe not all disease, but maybe it's causing some of the disease. So these two papers are both very interesting because they're slowly getting us closer to trying to understand how long COVID disease might be caused and what we might be able to do to treat it. But again, with both of these papers, I just need to emphasize again that these are a small number of patients that were chosen sort of from very specific groups for the study that didn't necessarily have a representative control, and where we have very difficult assays that are difficult to repeat at a larger scale. So they're really interesting starting points. And I think that they will be used for additional research on mechanisms of disease and treatments for long COVID very rapidly. But we're not there yet. So don't go, thinking that, okay, as we need to do something for clotting immediately and that's going to help. We don't know that yet. This is the first little inclination that maybe that is something that we need to look at really carefully. And people are following both of these studies up very carefully. And hopefully we will have more of that data soon that's going to give us a much stronger idea of saying, does this data hold up? Is this how long COVID works? And does that mean we have an idea to treatment? So this is really, optimistic in thinking of where we're going long term, that we are getting closer, but we are not there yet.
No, not there yet. There's still a lot, but I mean, thankfully, as time goes by, we get to know a little bit more, right? Even though it's true that it's been since quite early in 2020 that it was said, okay, there's more than just COVID-19. There's something beyond that. And yes, thankfully now we get to hear it a little bit more. There's more and more media that is talking about long COVID, is talking to even patients that have long COVID, so seeing their lived experiences. But is it enough, right?
Yeah, we need all of this research. We need patient lived experiences. We need reporting of patient symptomology over time. Patients have driven so much of this research. This is really, truly a patient-led movement, and we need that. But we also need these studies that are going into really detailed molecular studies trying to say, how is this disease being caused, so that we can start teasing out and saying, how might we be able to treat it? And, we, on both sides together, we are getting closer on the research side and the understanding side. But of course, as we've talked about so often, the difference and the division between the sort of research and our understanding side and the sort of awareness and advocacy and support for patient side is often a huge chasm, because still so many countries aren't even recognizing long COVID, aren't recognizing that long COVID occurs in kids, and aren't providing support for long COVID patients. And of course, we don't have a treatment yet. None of this says we have a treatment yet. We don't have a treatment yet. We're not there yet. We have a lot of very strong leads that we're still following up on, but we do have a lot of mechanisms of supporting patients medically. And unfortunately, that's often not being done, and patients aren't getting the exams they need. Patients aren't getting the care they need. So we really need to be bridging that, saying we have all of this research, patient-led research, science-led research, but we need to get also to that support level and that awareness and recognition level.
Especially it's long COVID is a worldwide problem. It's not only the privileged West, which yes, there you have clinics that are being created, you have some doctors that are talking more about it, and their support still not enough, but you have countries in the global South where there's no help whatsoever. And another fact is that barely any country is taking into account long COVID when they're dealing with the pandemic, when they're responding to this virus that just keeps on going, right?
Yeah, it is really, really tragic and unfortunate. And it's something that we are hearing about and seeing so much now, especially right now when we're talking about Omicron, when there's so much discussion about disease severity. You know, the idea of long COVID is all too often being completely omitted from that discussion. And it's a real problem. I mean, if we go and talk about Omicron, and anybody is saying, okay, well, it's less severe, that is always only applied to the acute infection, to the risk of hospitalization, to the risk of fatalities. And that's incredibly important. But that completely omits the fact that long COVID is incredibly severe. Yeah. And that's not being accounted for when we're talking about the disease, and when countries are implementing and planning strategies and mitigation measures.
This ties perfectly with our last part of our conversation, which is really talking about the situation right now worldwide with Omicron. So as by now everybody knows, Omicron was a variant of concern that was identified and then formally called a variant of concern at the end of November 2021 by the World Health Organization. And unfortunately, as we can see, it has spread basically everywhere. It has caused very, very high transmission in the community in many countries. And before you start telling us really, what is it, how is this variant different from the past one? What does it mean? What does it not mean? I would like to just quote something that I recently heard. Maria van Kerkhove, the World Health Organization COVID-19 technical lead, she said something very important this week. And I'm gonna just quote her because it brings to this idea of Omicron and how the media and people are thinking that it's mild. And she says, Omicron is not mild. It is not the common cold, and that narrative that is out there is dangerous and it is deadly. Omicron is certainly resulting in a lower risk of hospitalization, but both Omicron and Delta are infecting people. They're putting people in hospitals. And if you have huge numbers of cases, you will have an increase in hospitalizations. This virus will reach vulnerable populations, it will reach older populations, and we will see increasing deaths among them. Basically showing that what we say and how we act matters. So saying Omicron is mild, maybe that is true to a certain extent, but as so often we have spoken and you have said long COVID does happen to people that have had a mild COVID-19 case.
Yeah, it's a really important statement. I'm glad to hear that, because so when we talk about Omicron, which is what everybody's talking about right now, what exactly do we know? I mean, first of all, this is a variant that has more mutations than we've seen in any other variants before, which means that the potential for the variant changing how it behaves is higher. And this is unfortunately what we've seen. So we've seen the variant seems to be more transmissible, spread faster and faster from person to person. And this is something that we've seen with most variants. Each variant seems to get a little bit more transmissible. We're also seeing very, very strong immune evasion. So what that means is that people that had been, fully vaccinated with, say, 2 doses of Pfizer or Moderna or AstraZeneca are significantly less protected against an Omicron infection than a Delta variant infection. The same thing is true with people that had been previously infected, that they are much less protected against an Omicron infection. So we know that it's more transmissible. We know that it's more immune evading. And yeah, as the World Health Organization mentioned, there is some evidence that says, Omicron infections may be a little bit less likely to result in a hospitalization than a Delta variant infection. But again, it's really important because that's where this sort of it's less severe is coming from, that it's less likely to result in a hospitalization during that acute infection. But of course, less severe is not the same as not severe. And I think it's really well stated that if you have something that still results in a rate of severe infections, still results in hospitalizations and fatalities, just at a lower level, but you have so many more cases, then you are still going to overwhelm hospitals. You are still going to get many people needing hospitalization. You're still going to get many fatalities. And unfortunately, this is what we are seeing, because what we've seen in many countries is the sharpest rise in COVID cases that we've seen in the pandemic. And that is due to Omicron and how fast it spreads, but also how well it's able to evade immune protection. And so we are getting rapid increases in cases. And in many countries, they're now seeing and have seen the highest level of cases that they've seen in the entire pandemic. And of course, this is even occurring in countries that have very high vaccine coverage. And that's part of this immune evasion. And so we're seeing high cases. We're seeing increasing hospitalizations. We're seeing hospitals being overstretched and overburdened. And we can't say exactly how many people have had long COVID yet, but there is no reason to think that there is going to be any lower rate of long COVID coming from Omicron infections, because as you said, even mild infections have just as much likelihood of generating a long COVID case as a very severe infection. And so, you're having the highest level of cases in the course of the pandemic. So the number of daily new long COVID cases is going to be staggering. And so the overall impact on everything from hospitalizations to overburden of health systems to fatalities to long-term health impacts that are going to affect the workforce, that are going to affect the economics, that are going to affect the burden on the health infrastructure for quite a while is staggering. So Omicron is not a mild variant, and this is not having a mild effect where it is spreading. This is incredibly severe and creating an incredibly dangerous situation, especially because of this narrative of it being milder, means that there's less willingness to increase precautions. There's less willingness to take the measures needed to really slow the spread of this variant, despite the fact that we know exactly what to do. We've known what to do before, and we're still going to know what to do even when the next variant comes around, because of course, that's the other unfortunate thing is Omicron's not going to be the last. We're still waiting for the next one. What's Pi going to be like? What's the next variant? Because as long as we keep having cases around the world, we're going to keep getting new variants.
Yeah. And you're not being fatalistic by saying there's going to be a new variant. That this is not the end with Omicron, because the year before, we saw also the media, people, some scientists, some governments saying, no, this is over with Delta, the pandemic will be over. And no, that's not the case, because the more transmission there is, the worse it's going to be. So it's about, like we keep on repeating, right? Bringing the transmission down and keeping it down, because however you look at it, the more cases will translate to more hospitalizations, more deaths, and more long COVID.
Exactly. I mean, this is what we've seen in so many countries for such a long time in the pandemic. We have this yo-yo effect that keeps going on, that cases go up and countries take more precautions, and then those precautions start working, and then cases start to go down, so they release the precautions, and then give it a little bit of time and cases will go up again. Whether that's cases going up again from the same variant or a new variant, it's this cyclical nature. But the issue is that if you take precautions, maintain them, then you can try and block that cycle. It's not perfect. We're always going to be subject to, new variants coming in, how there's going to work. We're still going to have to adapt, but we don't have to have this dramatic cyclical cycle that we're seeing now if we stop dividing, coming up with policies that are based on what is happening right now and for the next 2 weeks. We need to look further beyond that. We need to say, look, this virus is still going to be here. It's going to continue to change. It's going to continue to cause hospitalizations, fatalities, long COVID for a long time. We need to act in a way that we can have precautions that are maintainable, that allow people to still have lives, to still, do things, to still work, to still do so many aspects of life, but keep precautions and keep it so that we keep cases down, so that we don't then have to dramatically rise precautions again and have lockdowns and things like that. Keep cases low through the precautions that we already know work.
That we know that they work, and that we need to do them, because we keep on talking about how to support, how to help, how to cure long COVID. But one other factor is prevention. You can prevent long COVID in the sense that the less COVID-19 there is around, the less long COVID there is. And just to end on a note, because I know some people really like numbers, they just want to tangibly understand, okay, what are we saying with long COVID? And this week, the Office for National Statistics in the UK, they reported that an estimated 2% of the UK's population is currently living with long COVID. And this information, this data, reflects the situation before Omicron.
Yeah. This is a really disturbing number. And, it's just, this is a huge number of people. And this is, of course, not just the UK. This is a huge number of people suffering from this disease. And this is, we don't know how long this is going to last. We don't have a treatment yet. And of course, this is not a mild disease. This is not, you're a little bit tired, this is a disease that can dramatically impact your daily life and can dramatically impact, if you're even able to go back to work, if you're able to engage in your daily activities. This is an incredibly severe disease. And this is a severe disease that is affecting at least 2% of the UK population already before Omicron. If that does not, instill this need to be taking more preventative measures to stop this from getting worse and to be supporting that percentage of the population that is having to deal with this and often having to deal with this themselves and alone, I don't know what will. It's an incredibly severe and dire situation that really needs action.
Yes. And hopefully this year, 2022, we will see that. Jeremy, as always, I could go on talking with you, but I think for this episode, we've done a good job. And that is it, right?
It's my pleasure. Always good to go through all of the, as much of the data, the current situation as we can, and, really just keep trying to get that information out there, because this is critical for people to know.
Exactly. Thank you very much, Jeremy, and see you next time.